Well, this is question from May June 21, 9709, variant 32, question number 11. With respect to the origin O, the point A and B have the position vectors given by OA equals to 2i minus j and OB equals to j minus 2k. Show that OA equals to OB, means the length OA is equals to the length OB, and use the scalar product to calculate the angle AOB. Now, this is simple part, very simple. So you are given the vectors OA and OB. You are given vector OA. OA vector is given as 2i minus j. So you can write 2 minus 1 and 0 for this. And so if OA is this vector, its magnitude is OA magnitude is 2 square plus minus 1 square plus 0 square, and this is equals to root 5. So the length OA is root 5. Also, you're given OB vector. You may label this as 1. So j minus 2k. J minus 2k is the vector OB. You may write for convenience this as 0, 1, and minus 2. So the magnitude of OB is 0 square plus 1 square plus minus 2 square, which is OB length is equals to 0 plus 1 plus 4, which is root 5. Number 2. So you can say that from 1 and 2, OA length is equals to OB length, the first part. And use the scalar product to find the angle AOB. Angle AOB. Angle AOB. Hence from angle AOB. Say you're given two vectors. This is vector OA, this is vector OB. These are two vectors given, OA and OB. The angle OAB, the angle at O is required. So the formula which you can use for this is the formula. Cos of angle AOB, is as the angle is at point O, right? OA and OB. Both vectors starting from O, because angle is at point O, divided by OA magnitude and OB magnitude. So we have the magnitudes O and OB given. So the magnitude of OA is root 5, the magnitude of OB is root 5. So we need the numerator, which is the scalar product. So the scalar product of OA and OB. So find the scalar product. OA dot OB, the two vectors are given. You may write in column just for your convenience. So 2 minus 1, 0, 2 minus 1, 0, and the other is 0, 1, minus 2. So the scalar product is equals to 2 into 0 minus 1 multiplied by 1, 0 multiplied by minus 2, which is equals to 0 minus 1. So the scalar product is OA dot OB equals to minus 1. So using let's label this as 3. Using 1, 2, and 3 in this formula, hence, therefore, the formula is cos of angle AOB, the OA dot OB, which is minus 1, divided by root 5, so which is cos of angle AOB equals to minus 1 over 5 using calculator. So AOB is equals to cos inverse of minus 1 over 5, and The final answer should be correct to one decimal place because this is angle in degrees. So 101 point, so 0.5 degrees. This is the answer there, correct to one decimal place. So this is the answer to part A of this question. And this is for 4 marks. Next part is midpoint of AB is M. The midpoint of AB is M. The point P lies on the line through O and M such that PA length, PA is to OA. This ratio is equal to root 7 is to 1. Find the possible positions for P. P is the point on the line through O and M. And first, we need to find the equation for the line O and M. And you can't find this line OM without knowing the point M. And M is the midpoint of AB. Well, simple. You're given OA vector. The position vector of A is given. This was 2I minus J or 2 minus 1, 0. If this is the position vector of A, then point A has the coordinates 2 minus 1, 0. You may do this directly or you can do this by first finding the points. OB is the vector given J minus 2K. J minus 2K means 0, 1, minus 2. So therefore, if the position vector of B is 0, 1, minus 2, so point B has the coordinates 0, 1, simple, minus 2. Next, as these are the 2 points and the position midpoint of AB is M, so simply recall the formula for the midpoint. Midpoint of AB is M. So M can be obtained by using the formula x1 plus x2 over 2, simple formula of the midpoint. So what is the difference? As you're dealing with the situation 3D. So write z1 plus z2 over 2, simple. So x1 plus x2 over 2, midpoint 2 plus 0 over 2, minus 1 plus 1 over 2, and 0 minus 2 over 2. So x1 plus x2 over 2 means this is x1, this is x1, this is y1 and z1, x2, y2, and z. So in this way, we have the coordinates of the midpoint M equals to 1, comma, 0, comma, minus 1. So this is M, and therefore OM vector is 1, 0, minus 1. So this is the position vector of M. So we have the point M, and P lies on the line through O and M. So the line is passing through O and M. Let us find the equation for line OM. Next, we'll find the equation of line through O and M. So this is the line. Just for the understanding, I can draw. There is a line passing through the points O and M. Here this point is O and here is M. And we have the vector OM in the previous step. So the line equation we know is R is equals to A plus T into B or lambda into B. T is the parameter. And we know that A is the position vector of any point on the line. So for convenience, I can take the point origin. So 0, 0, and 0. T is the parameter and B is the direction vector. So as the line is passing through O and M, and we have the vector OM, this can be treated as the direction vector. So 1, 0, and -1. So you can simplify this as T, 1, 0, and -1. This is the line OM. If this is the line OM, you can find this equation of line in the parametric form, because there is a point P on the line. So I'm looking for the coordinates of P. There's a point P which lies on this line passing through O and M, and we're looking for the possible position vectors of P. So P can be anywhere. It can be here on the left side on the in between O and, so P is the point on the line. So let us find the general point on the line OM. This is the equation of line OM. So the general point x is equals to t, y is equals to 0, and z is equals to minus t. So therefore, I can write P, the point, say here, the point P, and this point P has the coordinates t, comma, 0, comma, minus t. So this is these are the coordinates of point P, or you may write OP as t, 0, and minus t. So we have in terms of t, the coordinates of point P. So why we need this? Because in the condition we have PA is equals to PA ratio, PA is to O equals to root 7 is to 1. So OA length is given, but PA length is, so we need to find PA vector first. So P is there, and A point is already there. So you can find next, find PA vector. PA vector we know is OA minus OP. OA vector is given in the question, which is so for convenience I am writing this in the column 2, -1, 0, minus t, 0, and minus t. So in this way we have PA vector equals to 2 minus t, -1, and this is t. If PA vector is there, I can find its magnitude. PA is 2 minus t whole square, -1 square, and t square with under the root, which is, you can simplify, uh, use inside the bracket the formula for a minus b whole square. This is 4 minus 4t plus t square plus 1 plus t square root, and PA length is finally t square 2t square minus 4t plus 5. 4 plus 1 plus 5, and this is with square root. So PA length is here. Now using this important condition, PA is to OA. PA is to OA is length OA is equal to 7, 1. PA over OA, this means equals to root 7 over 1, or PA is equals to root 7 OA. PA length is here 2t square minus 4t plus 5 is equals to root 7 into OA magnitude is already in the first part is there, root 5. So 2t square minus 4t plus 5 is equals to root 35. 2t square minus 4t plus 5, squaring both the sides, 35. 2t square minus 4t minus 30 is equals to 0. So divide by t square minus 2t minus 15 is equals to 0. And from here I can obtain two answers for. So I can use the next page. Uh, so T is equal to, using the quadratic formula, we have the two answers. Uh, Two answers, T equals to 5 and T equals to minus 3. So yes, after finding these two answers for T, you can use these values here to find the position vector of P. I can label this as 1. So put in 1. So T is equals to if T is equals to 5, OP, which was T0 minus T, simple, T0 minus T is equal to 5, 0 minus 5 or 5i minus 5k. First answer, if T is equals to minus 3, if T equals to minus 3, yes, these two are the correct answers, T equals to 5 and T equals to minus 3. So if T is equal to minus 3, then OP is equal to, again, T0 minus T. So T0 minus T, minus 3, 0, and minus minus is plus. So the second answer is minus 3i minus 3i plus 3k. So these are the two position vectors. These are the find the possible position vectors of P. So these are the possible position vectors of P. So possible position vectors of P are 5i minus 5k and minus 3i plus 3k. So these are the answers. Thank you.